In this video, we're going to talk about minimizing variance of a portfolio. So finally, we're at a point where we've got some calculus and we've got some statistics and we can look at some real finance. So first, I want to talk about what happens with just a single stock. So we often talk about the expected return on a stock. So we believe Tesla shares are going to increase by 5% over the next year. Now, we typically refer to expected returns as a percentage rather than an absolute return. We have an amount of money to invest. We spend all our money buying shares. And what we care about is a percent return rather than the absolute return. So for example, if the shares are at $100, a $5 return is about 5%. Of course, if the shares are at $1,000, then a $5 return is a lot smaller. We're interested in the percentage return, the 5%, and whether the shares are trading at 1,000 or trading at 100, it doesn't really matter. What matters is how much money we invest and what's the percentage return. So for example, we have $10,000 to invest in a share worth $100, and we expect our expected return is 5% over the next year. So how many shares do we buy? And if we are right and the shares do increase by 5%, how much money do we have at the end of the year? And then, of course, the question is, what changes if the share price is 50? Okay, so if we look at this, we have $10,000 divided by 100. So we buy 100 shares in the first instance. The shares increase by 5%. So shares go up 5% means that the share price after a year is 105. We have 100 of those, and so we have 105 times 100, or $10,500. We have made $500 profit, or 5% of $10,000. So what changes if the share price were 50? Well, we have $10,000. We're going to buy 200 shares this time. The shares go up 5%, so they go up to 52.5. 52.5 times 200, of course, is 10,500. We have a $500 profit, or 5% of $10,000. Meaning, it really doesn't matter, as long as we have enough money, it really doesn't matter whether the share price were 100 or 50. If it were 50, we buy twice as many shares. The shares go up by half as much. In the end, we make the same money. Okay, we often measure risk using the standard deviation of returns. A stock with a larger standard deviation of returns has more risk, as it has a greater chance of ending up further from our expected return. So let's talk about portfolios for a second. So generally, we invest in more than one stock. We like to be diversified, and we'll talk more about what diversified really means. So we take advantage of the correlation between the stock returns to reduce our risk. And we measure risk, of course, using the standard deviation of returns. So we compute the standard deviation using, this is for a portfolio with two stocks. So the variance of a weighted sum of random variables is the weight of the first variable squared times the variance of that, plus the weight of the second variable squared times the variance of that variable, plus 2ab times the covariance of the two variables. And we're interested in the standard deviation, so we take the square root of the variance for that. Now, first, we're going to do an exercise where we create a portfolio with minimum variance from two stocks. So we're trying to minimize the variance. That should be a good calculus concept here. So if we know the formula for the variance, we minimize by taking its derivative, setting it to 0, and so on. So your expected return for the first stock is 6%. The expected return for the second stock is 8%. You analyze both stocks and you expect the standard deviation of the first stock is going to be 20%. Standard deviation of the second stock, or the returns on the second stock, is 15%. And we believe the correlation between the stock returns is positive 20%. Okay, so we're going to go through how to minimize the variance using calculus. So we let the percentage of the portfolio invested in the first stock be W1, and the percentage of the portfolio invested in the second stock, W2. And we know W1 plus W2 equals 1, namely the weights add up to 1, and 0 is less than or equal to WI is less than or equal to 1. So right now, what this actually means is that we're assuming we cannot short any stocks. So basically, we're going to have a positive percentage in both stocks. So we have covariance is the standard deviation, the first standard deviation times the second standard deviation times the correlation. First standard deviation is 20%, second standard deviation is 15%, correlation is 20%, therefore the covariance is 0.006. The variance of the two stocks is given by weight 1 squared variance 1 plus weight 2 squared variance 2 plus 2 weight 1 weight 2 covariance. Weight 1 squared variance 1 plus, now we can substitute weight 2 with 1 minus weight 1. So weight 1 minus weight 1, quantity squared variance of the second stock, plus 2 covariance, weight 1 times 1 minus weight 1. We know the variance of the first stock, that's the standard deviation squared. We know the variance of the second stock, standard deviation squared. Covariance we just calculated, and so we can substitute in some numbers here, 0.04 W1 squared plus 0.0225, 1 minus W1 squared, plus 0.012 times W1 times 1 minus W1. So we can take the derivative. Derivative of the first function, first term is pretty easy, 2W1, so that becomes 0.08 W1. Second one, we get a negative, we're doing the chain rule, so we get a 2 times the coefficient, times 1 minus W1, times the derivative of the inside function, which is negative 1, which is where this minus sign comes from. And then the derivative of the last function is 0.012, 1 minus 2W1. Okay, because this is, we multiply this together, this is W1 minus W1 squared, so it becomes, the derivative of that becomes 1 minus 2W1. So we are taking the derivative d var dW1, because that's what we're interested in changing. We set this to 0. We group all the terms with the W1, so we've got a 0.08 W1 minus 0.045 W1 minus 0.024 W1, and we get 0.101 W1 minus 0.033. Solve, and we get W1 equals 0.327, or 32.7%. That means W2 is 1 minus it. So the minimum variance portfolio is 32.7% of the first stock, 67.3% of the second stock. The expected return is return equals weight 1, return 1 plus weight 2, return 2. So that's